Okay, hello everybody. My name is Milan Unger. Together with me is Peter Mičuch. We both work in Siemens Healthineers as software architects, and we both work on the project which is called AI Pathway Companion. The intention of this project, AI Pathway Companion, is to bring new technologies, artificial intelligence and machine learning to clinical decision process. So it should help the physicians while doing clinical decisions, and also should help patients to improve their life while treated at the hospitals. So if you look at his project, it's actually the Greenfield project. So this is some luxury which you don't have every day. And there are multiple teams actually working on this project. So these teams are located in on different continents actually. So we have the teams in the United States, we have the team in Germany, in Slovakia, we have the teams in India, and these teams actually collaborate on the project. And all of this team has actually different skill set and has different backgrounds. So some of the teams are researchers, some members of the teams, or some teams are actually focusing on the research. Some of the team members are focusing more on the product development or on the software architect. There are plenty of the data scientists, and there are also external companies or teams working from the external companies and collaborating on this project. So what we are facing is that there are multiple different cultures, multiple different tool sets, and different actually approaches to solving the usually very similar problem. So if we look at the problem, so because we have this Greenfield project, so when you are deciding about the technical aspect of the project, of course, for the modern project, you will go with the microservices, and you would like to be on the cloud. So this is also our approach. We want to create the system based on the microservice-oriented architecture, and we want to be on the cloud. But if you look at our customers, which are hospitals, you need to realize that these hospitals are actually not willing to go to the cloud. And they are not willing to go to the cloud primarily because of privacy concerns. So they deal with the patient data, and this patient data must be protected. So because frequently in this patient data there are some private secrets, I would call. But simply physicians and the hospitals are not yet ready or not yet willing to go fully to the cloud because they are afraid that his privacy concern will be actually broken. So we have to be ready for the cloud, and in the same time we should be also ready to deliver our system on-premise. And if we look at his requirement to deliver on-premise, we are actually facing the situations that at the end we will have plenty of maintenance with the installations across plenty of the hospitals and across whole globe. So our main question is how to integrate these small microservices to various deployment which can be located really around the whole globe. And at the moment, during the pre-development phase or during the prototyping, we actually were also focusing on how to enable these teams, which are located also across the multiple continents, to deploy efficiently all microservices to our pre-development deployments. So what I will be talking now is our learning part, what we were actually doing, what we were trying, and how we come to some solution which really help us to be very efficient during these initial prototyping phases. And then later Peter will tell how we want actually to continue and bring this learning to our product development. So at the very start of the project, we decided, okay, the simple solution is we have the Microsoft Windows Server, and there is running Internet Information Services, so we will just deploy the web application on this server and use it as the working skeleton, which we can then present to our potential customers and get some initial feedback. From the developers' perspectives, they finish some task. It was working on their computers, and hurrah, let's go further. So we wanted to get it installed. Yeah? It's still just at the beginning. And then you find out, okay, what version actually is supported in Internet Information Services? What versions of the Python? What version of the Node.js is there? How to actually update his versions? And each of these teams actually used a little bit different stacks. For the researchers, it was typically Python. For the product developers, it was usually Microsoft .NET Framework. We had also the PHP services. We had some services which were running, or front-end running on Angular, and we had some front-ends running on the Vue.js. So this all has to be combined together. Then, okay, now you come to the problem. So which versions, but then is actually who can install and who is actually knowledgeable of setting up his software on his server. And it's not just on the server itself, but also on the developer environments, because if you have already something working on your computer, you must also test it's actually working with the other teams' microservice. So the next step was, okay, so let's assume we get running one system. So this was quite tedious work, but then you get it running, but then there comes product owner and said, okay, I want to get the laptop and use the laptop at the customer. So now you need to remember that, okay, what was the step to get this state actually working on his one server? How we can actually clone his one server to additional machines? So we started with the virtual machines. We make some really the images, yeah, and copies of the server, but this was really tedious, yeah. And another factor is how you actually get all these deployments when the administrator is not in the office. Yeah, so very frequently we had some deadlines, we had the iterations run, you wanted to do some demo, and during this time everybody was pushing, okay, I want to bring my new, latest, greatest piece of the software to the server, but there was just few guys available. Yeah? And especially if you work across the multiple continents, when there was something going on in the India, yeah, the guys in Europe were still sleeping. And when there was something going on in the United States, then the guys in Germany were already sleeping. Yeah? So this was quite tricky to get everything on time, and especially if you find out some bugs during the development, to get quick fixes on such server. So having these problems, so we started with the Docker containers. This is the logical step. Anyway, we want to be on cloud. We have the microservices. So it was just the next logical step, bring everything in the containers. For the teams, it was much more easier. So actually, from the architectural or from the system point of view, we did not care what's the stack. We just say, okay, choose your stack, but use it, yeah, and it's up to you how you will actually use it. There was no technology and version hell. Yeah, so we haven't cared what's inside the Docker, inside the container. We just use the container itself. And for the development teams, it was also much more simpler. Now they just go, okay, here is the container registry, and just deploy to the container registry your image, put here the latest label. We will always use the latest of your product, and then you are done, basically. Yeah? We just need to then restart it on the server. Again, it was much easier to clone the machine because we had some descriptions of these containers. We just downloaded the pulled images on another Docker engine and get it running. Yeah? So everything started to be simpler. And even the developers could reproduce this system. So before, when they wanted to test with the Fire server, yeah, which is the web service used in the healthcare, they had to always be connected to one or two servers which were running on the dedicated server. And when there was some issue with the connectivity, and typically if you are the big concern, it's not so easy to get inside the concern network, then they had hard time, and they had to reproduce everything on their own machines. This way, they just, again, downloaded the Docker image, can get it very fast installed, updated, and running. There was one new challenge. If you have like 25 microservices, and if you use just the simple Docker solution, you need to assign the port to every Docker image, and you need to properly configure the microservices and to connect various pieces of the system together. So the ports and the configurations were actually the next level of the HELM. And there was still one piece missing, because it was necessary to update and restart his Docker images. So usually it's not enough if you push the image to the Docker registry. You also need to have somebody who pulls the Docker image and get it running on the target system. And again, if there is no administrator at office, there was nobody to do this step. So there was still dependencies on some authorized person who can actually get the team's work finished, because whatever they committed, if it works on team's computer, it still does not work on the system which is presented to product owners or presented to customers. So when we look at his solution, we started to already think at the beginning, it was actually the longer discussions, that we will need to have some orchestrations of the Docker containers. There was multiple possibilities, there are still multiple possibilities. We can use Docker Compose, which is very simple. We can use Docker Swarm, or we can use Kubernetes. But for us, the main question was how to automate the deployments. So we were looking at the possibility to automate the deployments. And we were looking at the possibility to automate updates of these deployments across various stages and various systems. So we always wanted to have system on-premise, to have system in cloud, so we can actually compare how it works, get some experience. And we also wanted to have multiple stages, not just the latest one. And yet another task was, okay, we want to get rid of calls and mails, please update my image. We wanted simply that teams will self-serve and will get things installed in the automated way. So we decided for the Kubernetes. The reasons for deciding for the Kubernetes was that it's well supported by the cloud vendors. It's relatively easy to get it running on the bare metal systems. So we actually have on-premise installations, few nodes, small cluster, where we can test it. And it's also easy then to get installed on hospital premises. So in the hospitals, you have data centers, you have virtual machines, and it's actually not too big challenge to get the cluster running. But in addition to Kubernetes itself, we wanted to extend it with this automated updates mechanism. So if you look at the Kubernetes, you can change the images, but you usually also need his administrator access. So somebody has to change the manifest, or somebody has to upload something to the Kubernetes. So this was one part which was missing for us in the plain Kubernetes. So if we look at our solution, for each microservice, we defined the deployment. And in this deployment, we actually defined the container, where each container has actually the name corresponding to a given microservice. So depending on which part you was implementing, you just decided for the name. And then we always use the specific label. So for the heat development, or for the newest development, we use the label latest. If the team want to present to product owners during end of the sprint, what was done, he can use the label sprint. So by his change of the label, we ensured that they can get something ready and in the same time still work and break the system on the latest system. And then we have additional label which is called demo. And this demo label actually means that, okay, there are just the systems which are ready for showing the system to potential customers. Now we have also label for the product, but the productization is a little bit different because there we follow a little bit different path. But for the pre-development, where we want to be quick and still keep the system somehow stable, so we can really present to the customer, or we can present our system at the conference without having it destroyed by the latest update by some developer in the team. We simply decided for these 3 simple labels. Next to it, we have service for each, so service as the resource in the manifest of the Kubernetes, which describes this microservice. And we use the standard port everywhere, so we get rid actually of the port health. Yeah? So each of our services use standard HTTP port. From the developer perspective, he finished his works on his computer and pushed the changes to continuous integration system. Then we have the container registry, which is running in the Azure. And actually, the developers just make sure that his latest image is available in the container registry. Next to it, instead of administrator pulling the images, we have central job, which actually looks at the pod version, so the version of the image in the pod. And if versions between the pod and the image registry, container registry, is different, the pod is deleted, and the Kubernetes itself take care of pulling the image from the registry and replacing it in the pod itself. So the trick is actually by specifying the image pull policy always. So if you don't specify his image pull policy always, you get just the local image. But by simply specifying his image pull policy always, each time you delete or restart the pod, the new image is downloaded if there is the fresh image. Yeah? But somebody has to delete his pod, and this is actually the trick here. We do it by this central job. So it's easy to deploy now. So once the team is done, and they actually push the new image, new container image to registry, in some 10 minutes, the system is updated. So we get actually 6 deployments, or we are still using 6 main deployments. So we have 1 deployment on-premise, 1 deployment on cloud. On each these deployments, we have 3 stages. So we have latest, sprint, and demo. And it's very easy to reproduce the system. So we also created a specialized deployment. So some of the deployments are for the developers, like smaller system where not everything is needed. Then we have also specific deployments when we try to integrate with the different vendors. Yeah, so all what you need is to apply manifest of Kubernetes. As the result, we get automated updates by the central script, so the teams can actually self-serve. And we also get independent and self-controlling teams. So while having microservices, we don't need to do micromanagement. We are not pushing anybody to, okay, please give me this or that state, or expecting that they will request somebody to allow them to deploy something new. They can make their own commitments, and once they are done, when they push the image, they actually can expect some results. There is one gotcha. We have just 1 script, which is running centrally, which means that if this script fails, then there is no update. And additionally, if we wanted to create a new deployment, then we had to edit the script and add all deployments or add additional deployment to this script. Yeah? So this was still one limitations of the system. Anyway, these 3 steps already helped us a lot. So everybody gets satisfied, because before we had a lot of the troubles that when there was the product owner showing our system at the conference, we got the mails, please do not touch on Friday the system, because we want to avoid that you push something and destroy our great conference. So we actually was like, okay, so I can do something, but I cannot try it integrated. But with this change, we already actually get everybody able at any time to push the latest. So in the latest stage, there was always something which developers wanted to see, sometimes not working, of course, because you do mistakes. But at the same time, we still keep the stable demo stage. And if the team decided after synchronizing with the product owner, the result is already ready for the presentations, for the shows, then they can just retag the image and the new state will be available in the demo stages. And at the same time, the all systems were actually up to date, yes, without any extra delays because somebody was not in office or somebody has not access rights to some of the system. So now I will let Peter to continue with more advanced step.
Thanks, Milan. Okay, so when I joined the project, this all was already decided. There was no decision. You can decide if you work with Kubernetes or Docker Swarm. So this was already there. So I could just improve whatever was there because we already invested, right? So I hope I push the correct button now. Yep. So I continued with the team with the next 4 phases. Some of them were running in parallel. By the way, how many of you is already working with Kubernetes? Okay, so I have to be careful not to say something which is not true. Okay, so we needed to improve first this auto-update of the Docker images because currently we had one weak point. Actually, that was Milan's machine because the script that he was presenting before was actually running on his developer machine. And whenever he got out of the office and this machine happened to update itself, the script was not restarted. And then everyone was waiting until Milan is coming back or doing something manually. Of course, we could go for virtual machine or something like that, but still, you have a piece of software which runs outside of the cluster, and that's not good. So what we had, what Milan presented, is actually we have a cluster with many pods. Then we have developers pushing their changes to the container registry. And then we have this script that checks whether there is any discrepancy between the images that are in the pods and in the container registry. So whenever there is a change, as Milan said, we delete the pods are gone, and restart it again. So we want to avoid this component here. So what we went for is the situation is, well, mostly the same, but the machine on Milan desk is missing this time. It's still there, but we don't need it anymore. So what changes this pod over here? Inside this pod, we are actually using Kubernetes client libraries. They are available in multiple languages, Java, Go, or even JavaScript, you may decide. We use .NET Core because that's where at least I had most experience and I was writing this script myself, so we use that. What this script does is actually whenever there is again some change or commit, this pod checks internally using these APIs what is the version of the image that is currently used by any container within the pod, because of course pod may have multiple containers, which we don't practice too much, with some exceptions. And then of course it checked using the Docker image API version 2, what is the hash of the image in the container. And since the Kubernetes stores this hash a little differently than the one that we have in the container registry, what we've done inside these pods, we actually use the annotations. So we store inside the annotation of each pod the digests or the hashes of each container. So whenever this digest is different, again, we trigger the same thing, this time not externally through the kube control command, but internally through these Kubernetes APIs, and the pods got deleted. As you could notice, also the pod which controls the whole system got updated itself. So whenever you have some improvement to your update mechanism, you can just push the new version of container and it updates itself as well, just as any other pod. But the situation here is maybe those who work with the Kubernetes notice that it's not really optimal. Milan mentioned that we have 3 stages. We have sprint, demo, and latest. But the problem is that this latest is not deployed just on one cluster. So we have multiple clusters, and if you have some dependencies to your software, for example, we have a Click software which visualizes different graphs. And if you are updating, and this is external software for us, and if you are updating your image to use the latest Click, but the Click is only installed yet on next to one of the clusters, the problem is that when you push the latest, with this mechanism, you update all the clusters at once, even those that are not ready yet. So for the next step, we would need something like update of the configuration. So not just changing the Docker image, but rather pushing new Kubernetes manifest files. And to explain that, I'll probably talk a bit about how our manifest files looked like and what was our solution for keeping them. So what we had was a Node.js script at the beginning. Later on, due to some product reasons, we had to rewrite it to PowerShell. And this one actually takes as an input file like this. It's not very nicely visible, but it's a basic JSON file. And inside this JSON file, there are multiple sections. We define what this deployment will contain, what kind of templates. So basically, each template represents one microservice. And out of these microservices, you build your entire application, right? So we have templates. And inside these templates, we have some placeholders you will see later. And for these placeholders, what we do, we define some default variables. For example, these can be resources like CPU limit consumptions, memory limit consumptions, how many replicas of your pods do you want to run. But of course, you may have some defaults, something which is common for your all clusters. In our case, it's, I don't know, cookie expiry timeout for the authentication service or something like that. So these may be defaults. And then we had another section in this deployment file, which is variables that are specific to your deployment. So if, for example, developer on his machine in the Minikube, he doesn't want to every time type in the login and password when he tests his application, he just disables the authentication, which is, of course, in cloud and in our internal network by default enabled. And he wants to disable it, and such things like namespace you may override. And as I said, for every microservice, we have a separate template. So there is many templates by now. For prototype, I don't even count. There is many. They look something like this. So each template is just like any regular Kubernetes manifest file. In this case, it's deployment, can be stateful set, whatever. And then there are these master syntax variables which are actually replaced by the script. When we run the script, it takes the script from the previous file, this JSON file, and replaces all the values and combines all templates into single manifest file. And this single manifest file you just apply to the cluster and everything gets updated. For those who work with Kubernetes, this probably looks very familiar, doesn't it? So if you look at HELM, the structure is pretty much the same, but much better. They also have templates, but inside their templates, you actually can use a Go template language with some extension functions. So you really get much more functionality, not just a simple value replacement. They also have values, which are our variables. They are structured, also have some levels of overriding. And in addition, they have this requirements YAML, which actually defines what requirements your software has. So you can build charts and start to compose your application from already smaller tested pieces. But that's not just Helm. There are other things, for example, like KSNet with JSONnet. Unfortunately, that one was, KSNet was discontinued, so that's not relevant anymore. There is also Customized from Kubernetes, which is a native solution. That's more in the arena of configuration management. But we are still not decided here yet what do we use. So currently, we still have our plain YAML files, which we compile every time we want to push something to the side. But for product, we definitely need to come up with something better. At the same time, we every year start, it's called Summer Academy Project, so we wanted to have students solve our problems for us. So what we've done is we gained 10 university students in Žilina, and we gave them these requirements. We told them, well, we have hospitals, so that's a lot of clusters that we will need to manage somehow. We want to have different configuration in each hospital because, of course, they may have both different versions. And we need to manage it all remotely. So we of course showed them whatever we have today in the system. We gave them some course, really quick course to Kubernetes. They've never worked with Kubernetes nor Docker before. And the outcome that we got was, I would say, improved version of what you've seen before. So we again had in Azure web service with some portal which you could use to configure it. And then we had a lot of simulated clusters on the students' computers. They installed Minikubes. And what they've done is actually they had just database of different versions of the YAML files, and these pods, they copied the idea and just took the YAML files that were configured for specific cluster and applied them. So using, of course, kubectl from inside the cluster. So what we ended up was a lot of versioned YAML files. Unfortunately, it was not ready for update at all, because they just used the kubectl apply for a single file. The problem is that it doesn't clean up your cluster. So whenever you add services, you are fine, but removing services doesn't work this way. So we concluded that this was probably a homegrown solution syndrome, because they concentrated too much on what we already had. And the phase that is just ahead of us, and we are going to do that for the product, is we need to really now go from experiments to real life. We need to deploy to many clusters. So we will now really need this control version of deployed applications and infrastructure, and we will need to somehow manage also values and secrets which are different for different customers. So for example, in a hospital, we are scraping data from the databases into our internal system to later on analyze it and run, I don't know, NLP algorithms on top of reports from the physicians. And for all of this, that's very specific for each site. So even though you are deploying the same application, the configuration and the settings are totally different, right? So IP addresses and the passwords, everything is different. So what we are considering now is actually we are looking at the Argo project that's based on the GitOps and takes a Git repository as the source of truth. So whatever you check into the Git is then applied to your cluster, and you actually can see how the deployment goes on. You can see how everything goes visually. They support also HELM charts, and they support plain YAML files, and you can actually write any plugin for your own homegrown solution if you like. And we are also looking at RASI. I don't know if you know that one, that was developed by IBM for about 2 years and released in May, I think, for open source, so everyone can contribute now. That's a solution that targets exactly use case we like, but I think even in a bigger scale, because they are using it to control, I don't know how many thousand clusters around the globe, and also applications that run on these clusters. And they are also using a pool principle, so scalability is not an issue in this case. And one more thing that we need to have a look at, those who are working with Kubernetes would probably say that we should have looked at it when we selected Kubernetes at the very beginning. So we need to monitor cluster health. We need to collect logs somehow. So that log collection we already managed. For that we are using Elastic. Again, the problem is that we run on-premise, and we cannot really even push data out of this cluster. We can get to container registry, we can get to some predefined addresses, but we cannot just collect logs and get them outside of the hospital, because this is treated as also kind of privacy data, what they are doing inside. So we are running Elastic locally and connecting remotely if you need some debugging support. We also evaluated Azure Log Analytics, but after contacting Microsoft, this is not supported for on-premise. You can really use it just internally in Azure. Otherwise, this would be also a suitable solution. We already have other projects which have experience inside Siemens with this. And for monitoring, Prometheus is what we are going to utilize. In our case, this supports alerting, has quite a big community. And Grafana, which is usually #1 choice for the UI for the Prometheus, also supports access to Elastic. So we plan to probably replace Kibana with Grafana later on. So these are the 4 phases that either we accomplished already or are still running. If you would start with Kubernetes, or if you did already, I think you already skipped to the last phase, hopefully first. If not, you should. And that's basically what we wanted to show you, how the journey was for us. And in case you have any questions, you can ask now. Yep.
Why did you decide to choose the complicated way of labeling your Docker containers with the latest tag instead of using, I don't know, SHA-256 sum or using the git tag, git committed as a tag to control which exact version of the container and code are you shipping to certain cluster, certain deployment?
So the main reason was that you really deal with the different teams and his different skill set. So for some of his teams, they are not used to continuous integration, for example. So we wanted to simplify. So make it as simple as possible. And we also wanted to avoid that they always need to get access somewhere. Yeah? So the one possibility will be like Argo ML. So now we are also looking at for the product, it's actually not really the solution. In the product, you need to actually control the versions.
And that's actually how it's done in product. So in product, we are really using hashes, not labels.
But if you're in the prototyping phase, you just want to be fast. Yeah? And there are small teams, sometimes there are 2 people who just really want to quickly push something and show some updates. Yeah? It's a little bit different between the productization phase and between the prototyping phase.
But I totally agree with you. Even for prototyping phase, this is valid point, and that's what I said. We don't want to just push images. We want to rather apply configuration. And within this configuration, that would solve the problem that you have 2 clusters, and on one cluster you are ready for the latest stage, but on the other you are not. So there I would rather push configuration with exact hash, use this image. That's, of course, yeah.
Yes. And to the question that not all of the teams are that advanced in the continuous integration technologies they use. Well, normally that's the infrastructure team who provides the CI infrastructure, which is common to multiple projects.
Yeah, but we wanted to avoid it actually, because we have, so at the moment we have like 50 people, and if you are always depending on the one team, and then you actually push to all teams one solutions, yeah, one size fits all, yeah, and we wanted to avoid it. So we actually wanted it, okay, it's up to you how you decide, but you should also then be responsible in deciding when you push and when you commit your changes. So actually we have, and there is also another factor that we have different organizations. So this is not just the Siemens Healthineers, there are also some research center, and some of them does not have connectivity to our network. So even if they have some continuous integrations on their own side, it's not unified. Yeah. So at the end you needed to actually have some point of the contact where you synchronize all these pipelines and all these streams. Yeah. And this, for us, it was this one registry, container registry. In the product, again, if you go to the product, there is, especially if you go for the medical devices, the process is very strict. So this is completely different situation. So this is the solutions where we actually aim to just to enable these pre-development teams, which are really experimenting. Sometimes you have situations that UX guys goes to the hospital and they get the feedback and they say, okay, yeah, please can you try to change something? Yeah? And you don't know if this will be the correct solution. Just maybe experiment, yeah? And then they show it again to the physicians, to collaborating hospital. And that's actually very fast cycle. And sometimes you can invest, yeah, and sometimes it helps, but sometimes it could be actually blocking you because then you are connected to some process. Yeah.
Are you still staying with that homegrown solution? Not using the HELM 2? Are you looking forward to the HELM 3 and going to implement it?
So the question is if we are staying with the homegrown solution, because they cannot hear, so I'll just repeat. Well, for now, yes. But we don't want to stay with that definitely. We are now, there is a Helm release beta in August for Helm 3, where you will get rid of the tiller. in the backend. So probably when this one is out and stable, we would switch. For the product, for the prototype, we want to switch, but unfortunately there is no one who would do that right now.
So maybe
and the solution works, right? It's much better than, well, when they started with IIS, that was a disaster, I would say.
So maybe also the history behind, even when I was writing this script, I was aware of the HELM, but there was quite high pressure. So for me, it was decision, okay, go to study the HELM and find out if it works for me, or spend 4 hours and write your own script. So it's basically just the mustache template. It's not big science, yeah? So these were simple decisions, and then I immediately said to the team, okay, please, because there is a special team also responsible for this. I said, please rewrite it to the HELM. But somehow they still keep it, yeah. It's really, it's poor man's solution, I would call it, yeah, but it works. But HELM will be definitely. That's actually one of the messages, yeah, what we want to say. You can do some learning path, but if you, from the scratch, start with the HELM, with his Argo ML, if you look at the RASI and all these solutions, we can actually skip all these steps and get actually to proper solutions much faster.
If you have someone with proper knowledge, then definitely go for a solution which is already there. That's, that would be, by the way, the message, right? So.
But not
you mean instead of pushing image and pulling it from one central repository? I'm not sure what exact advantage would we gain, because then you need to maintain this registry, right, locally, also on your own premise.
Okay. Another question is if you are also handling securities, checking integrity of images, DevSecOps and stuff like that.
In products.
Yeah. Ongoing process, like by default secure, check somehow.
Yeah.
In product we do. Again, differentiate between rapid development and product development. So one thing which you need to realize, if you go for the medical device, I will again repeat it. If you go for the medical device development, the process is very strict and it slows you down. So like, for one bug fix, you need to spend like a week.
So slow it's secure.
No,
really.
no, I don't mean that. I mean that, but you need to have this security. But we have, in parallel to this, we have this pre-development and prototypes teams. Yeah? And these actually want to be very fast. And here we compromise on a lot of the things, but because we want to get rather fast feedback. So what we want to avoid, because this strict process slows us down, that we will invest heavily in some development and then we get the feedback from the physicians, yeah, okay, but I want it a little bit different. So really getting fast feedback we do in the pre-development phase, and here we focus on the speed, while if you go to all security, all this version management, a lot of the regulatory aspect, as I said, if this approach with the latest will not work in the product, because you cannot actually push new microservice without complete regression test in the medical device industry. Yeah? So we will be actually mandated to do complete regression test and has the test report. Yeah. Yeah. So this is for the rapid development. If you want to be fast, if you want to productize something out of that, you need a little bit different approach, or maybe.
Well, you don't care unless in prototype some security aspects, right?
Yeah.
So. Yeah.
Yep.
Thank you.
Okay, thank you.